Hi, in this video we're going through Primary 5 Math, the topic of fractions. We're looking at some examination questions, and these are the types of questions I'll be looking at. Alright, so I won't be going through. You can look at it from the printout. What is the value of 4/5 divided by 8? So to work this out, you need to take 4 over 5 divided by 8 is equals to 4 over 5 divided by, you need to realize these are 8 is equals to 8 divided by 1. Alright, then after that, for division, you need to change this to times, and you need to flip this around. So it goes to 4 over 5, change to times. 8 over 1 becomes 1 over 8. Okay, and for this becomes 4 times 1 divided by 5 times 8 equals to, now if you're familiar with cancelling, then you can do 1 and you can do 2. Alright, so divide by 4, you get 1, divide by 4, you get 2. So 1 times 1 is 1, 5 times 2 is 10. And that's the answer. Alright, so in this question, I want you to be familiar with how to change the divide sign into multiply sign. Alright, in the multiply sign by flipping over this. Alright, I want you to try this yourself. Don't just look at me do it. It seems very easy when you look at me do it, but when you try yourself, sometimes you get a bit confused. Okay, so make sure you know how to do this kind of division of fractions. How many eighths are there in 1 3/4? So you take 1 3/4 divided by 8 is equals to 1 over 8. Alright, so you have to realize this. 8th is 1 over 8, 10th is 1 over 10th. So if I have something like 10th equals to 1 over 10th, 7th is 1 over 7. Alright, so every time you see that TH at the back is actually 1 over. So 1 3/4 divided by 1 over 8. So how many eighths are there in 1 3/4? So you change this to improper fraction, 4 times 1 plus 3. So 4 times 1 is 4 plus 3 is 7 over 4 divided by 1 over 8 equals to 7 over 4 again. You see this? Alright, so let's change to times. This one flip over times 8 over 1 equals to 14. So there are 14 eighths in 1 3/4. There's another way you can solve this. So basically 1 3/4 is 1 whole and 3/4. Alright, so 1 whole, how many 1/8 are there in 1 whole? So there are 8 times 1 over 8, alright, equals to 8 over 8, so that's 1 whole. So this part has 8. Now this part is 3/4, and you need to make it the same denominator as the 8th, alright, so you need to times 2 times 2 equals to 6 over 8. So it's the same denominator, so in 3/4 there are 6 1/8, alright, 6 of 1/8, so you take 6 of 1/8 plus 8 of 1/8, so it's 8 plus 6 equals to 14. So it's 14 1/8. Alright, so this is another way you can solve it. So you just take the 1 whole become how many eighths, and then after that you take the 3/4, you make them the same denominator of the 8th, and you take times 2. If you times 2 at the bottom, you times 2 on top. Then you get 6 over here, and you take 8 plus 6, you get 14. So that's 14 eighths in 1 3/4. What is the missing number in the box? So you got 3/5 plus 3/10 minus half equals to how many? 5. Okay, so you need to, for this kind of question, you need to make all the denominator the same, right? So you make the denominator the same. Let's do it now. So you have the lowest common multiple between 5, 10, and 2 is actually 10. So you have to realize that. And to do that, I need to multiply by 2. So if I multiply by 2 below, I need to multiply by 2 on top. So this one remains the same. I multiply this by 5, multiply by 5. And I'll get 2 times 3. 2 times 3 is 6. 2 times 5 is 10. Plus 3 over 10 minus 5. 1 times 5 is 5. 2 times 5 is 10. Equals to 6 plus 3 is 9. Minus 5, so that is actually equals to 9 minus 5 is 4, right? So the answer is 4 over 10. But the answer provided. Denominator is 5, so I need to simplify this. So divide by 2 becomes 2, divide by 2 becomes 5. So it's 2 over 5. So the answer here is, the missing answer is 2. So in this question, I want you to learn how to convert everything into the same denominator. So once you get the same denominator, once you have plus and minus, you need to convert your fractions to the same denominator. Then you can plus and minus your fractions. Once you get it, then you simplify it to the simplest form. Now, Ping Ping thought of a fraction. He multiplied the fraction by 25. Then he added 8 to the fraction. He got 23 as the answer. What is the fraction that Ping Ping thought of? Express the answer in the simplest form. Okay, so Ping Ping thought of a fraction. Just put a fraction as a question mark. All right. He multiplied the fraction by 25. So the question mark times 25. Then he plus 8 to the answer, and he got 23 as the answer. All right. So to get this question mark, you need to do the reverse of what he did. So when I get 23, so if I want to get this part, all right, this part of the so-called the answer, so I need to take, for this part, it's actually 23 minus 8, right? Because I plus 8 here, right? So therefore I need to minus 8 over here, which is 15. So this part is actually 15 because I minus 8, I get 15. So question mark times 25 is 15. So what is question mark? So I times 25 here. So therefore I need to divide by 25 over here. Then I'll get my question mark. So question mark equals to 15 divided by 25 equals to, this is 3. Divide by 5, you get 3, 5. So it's actually 3/5. All right. 3/5 is your original fraction. So let's just check. 3/5 times 25 equals to 5 equals to 15. And I plus another 8. Oh yes, I get 23. That's correct. So my answer is 3/5. Now, I just want to quickly go through and explain in more detail, emphasize, all right? So write out the whatever, is in words over here, whatever that is in words, write it out in math. So what does writing out in math first means? So you think of a fraction, just put a question mark. I don't know what is this fraction, just put a question mark there, that's fine. And then I multiply it by 25, so just put multiply by 25 over here. All right. Then I add 8 to the answer, so I write add 8 to the answer. Then you got the 8. And equals to 23. So he got 23 as the answer, means equals to 23. All right. What is the fraction that Ping Ping thought of? Express the answer in the simplest form. So once you have this, right, then it's easier for you to sort of figure out what is the question mark over here. You have the 8. So if you plus 8 here, so therefore when you shift over, all right, to get this part, you need to plus becomes minus, minus becomes plus, times becomes divide, and divide becomes times. Right? So if you plus 8 here, so I mean, logically or using common sense, you also roughly need to realize that I need to minus 8 here, then I can get this part over here. All right? So once I get this part is 15, then I can work it out by taking the question mark times 25 equals to 15. So to get the question mark, I need to divide by 25. All right, times becomes divide, plus becomes minus, minus becomes plus, and divide becomes times. And then over here, just convert it to the simplest form. Okay, so try this question yourself. Make sure you know how to do it. This person used 9/10 kg of flour to bake some muffins and bread. She used 1/3 of the flour to bake muffins. How much flour did she use? Okay, this is quite a tricky question, right? It's 9/10 kg, so be careful of this. 9/10 kg is equals to 9/10 times 1000 grams. All right, equals to 900 grams. So 9/10 kg is an absolute amount. It's 900 grams, all right, or 0.9 kg. A 1/3 of the flour is 1/3 of the flour. So this amount of flour can be anything. It can be 1 kg, it can be 10 kg, it can be 1 million kg. All right. So it's just 1/3 of the flour. When you see the word of, then they put multiply over here. So be very careful with this. 910 kg is an absolute value. It means 900 grams or it means 0.9 kg. It's an absolute value that you can actually carry and see. 1/3 of the flour is, you don't know what is it. If I just tell you 1/3 of the flour can be 1 million kg. Alright. And 1/3 of the flour is 333,333 kg. That's quite a lot of flour. So it really depends on what the flour is. So be very careful about this kind of questions because it's very tricky. So 910 kg, just right here is 0.9 kg. All right. Remind yourself this is an absolute value. This is just one single value of weight. And then she used 1/3 of the flour. So this flour actually refers to this 0.9 kg. So 1/3 times 9/10 or 0.9. So this 9/10 is actually the flour. All right. So 1/3 of this flour, of is times this flour over here. So you cancel 1, cancel 3. So it becomes 3/10 what? The units is 3/10 kg. All right. So it's actually, she used 300 grams to bake the muffins. Yeah, so be very careful with all these units over here, especially when you see this kind of questions. Looks easy, but just tricky in terms of the units. All right, so just take note of it. Okay, this person bought 4 chiffon cakes. She cut each cake into 9 equal pieces. She gave 2 pieces to each of her 3 friends. What fraction did she left? So 4 chiffon cakes, 1, 2, 3, 4. Each one got 9 pieces, 9 pieces, 9 pieces, 9 pieces. She gave 2 pieces to each of her 3 friends. So in altogether, I have 4 chiffon cakes divided by 1/9. Right? If you don't see this, right, you can actually just scratch this out. And you realize that each cake has 9 pieces. So 4 cakes times 9 pieces equals to 36 pieces. Alright, so in total I have 36 pieces. She gave 2 pieces to each of her 3 friends. So now she has 3 friends. And she gave 2 pieces each. So altogether she gave 3 times 2 equals to 6 pieces. What fraction of the chiffon cake did she left? So 36, you need to minus 6 equals to 30. So she left with 30 pieces. So the fraction is 30 over original is 36. Alright, so divide by 6. This is 5. And this is 6. So she's left with 5/6 of her original chiffon cakes. Gwen and Penny shared 252 in the ratio 2:7. So you have Gwen, you have Penny, and you have total. So the ratio is 2:7. Total is question mark. Alright, total is 7 plus 2. Alright, 2 units, 7 units. 7 plus 2 means 9 units. And 9 units is actually 257. How much did Penny have? So Penny had 7 units. So a lot of times people do 1 unit and then I find 7 units. So 1 unit is 257 divided by 9, and I take this answer times 7 over here. Now I want to show you another method which might be easier, might be more difficult. So every time you come up with this is what I call the divide times structure. Alright, so use this, you can skip a few steps here and there. So you just take 7 units. So you have 9 units is 257. You want to find 7 units. You take this, divide it, and then times. Alright. So you need to put your units in the same column, your dollars in the same column. And then you take divide times. That's why I call it the divide times structure. So it's 7 divided by 9 times 257. Alright. And this will give you the answer as well. So you can do both ways. So in this question, you need to know, I want you to set up the people that are involved in this, all right, and then these are the values that they have. So I call this my mathematical structure, and I call it the mathematical structure because if you have a very long problem sum, often you can change it to this kind of structure. All right, then the people on top, and then all the values in the bottom. All right, and whatever they did on this side. Okay, so as you go forward in your math, you will see this kind of what do you call it, questions, and I'll be using this a lot. Okay, so this combined with your divide time structure is super useful for you to solve questions quickly. So 7 over 9, so you just divide and you get the answer. Which of the following fractions is smaller than 5 over 9? So whenever you see this kind of smaller than, bigger than, right, you need to change the denominator, which is the bottom part, to the same. Alright, to the same as this. So 18, so you need to take 5 over 9, then you need to take 5 over 9 times 2 times 2 equals to 10 over 18. So it's 10 smaller than this? Yes, it is actually smaller. Let's try the rest. So 5 over 9, 27 is times 3. Make the denominator the same. So if you times 3 at the bottom times 3 on top, becomes 15 over 27. Is it smaller? No, 4 is smaller than 15, so nope. So 5 over 6, this is 5 over 9, so you need to find the lowest common multiple, which is 18, so you need to times 3 times 3, which is 5 times 3 is 15 over 18, and 5 over 9 times 2 times 2, so it's 10 over 18. So 15 is bigger than 10, so this is not smaller. So 7 over 12, so do the same thing, find the lowest common multiple, and then compare the numerator. Alright, so find the lowest common multiple for the denominator and compare the numerator. So for 12, right, it's actually 36, so times 3. 12 times 3, 9 times 4. Okay, so work it out, but the answer is this one. So for this question, every time you see smaller, you see bigger, you want to compare fractions, always change the denominator to the same as the one that you want to compare to. And if, let's say, you cannot just times easily, then you need to find the lowest common multiple for the denominator. All right, and then you compare the numerator. Okay, so that's how you solve this kind of questions. Which of the following does not have the same value as 3/4 minus 1/8? So 3/4 minus 1/8. If you are minusing fractions, you need to make the denominator the same. Alright, so need to make the denominator the same. So this is equals to, I need to times 2 here, times 2 here, 6 over 8 minus 1 over 8 equals to 5 over 8. Alright, so which of these does not have the same value? So 1 minus 9 over 24 is 24 over 24 minus 9 over 24. Right? You need to realize that 1 is actually 24 over 24. You need to make it in the same denominator. Alright? So 24 minus 9, work it out. Simplest form, see whether it's the same. Half plus 1/8, same thing, times 4 times 4. So see whether it's the same. 1/8 plus 5, interesting. So 1 over 8 plus 5 is equals to, you want to make it to the same denominator, is 1 over 8 plus 5 over 1. Alright, 5 is the same as 5 over 1, so I change it to 8 times 8 times 8. 1 over 8 plus 8 times 5 is 40 over 8. And then work it out from here, so just 41 over 8. 20 times 1 over 32 is equals to 20 over 1 times 1 over 32 equals to 20. Then you take the top and you multiply the top, so 20 times 1 over 1 times 32. And then you work it out, change to the simplest form, and you see which one has the same value or not. Alright, so work out this question by yourself. Daniel bought 7 over 8 kg of sugar. He used 2/3 kg to bake cakes. Now how much sugar actually left? So again, it's 7 over 8 times 1000 grams, which is an absolute value, some kind of grams. Now this one is, he used 2/3 kg to bake cakes. Okay, so it's 2/3 times 1000 grams equals to some absolute value as well. So this is different from the question above, because the question above is 2/3 of the flour. So it's 2/3. The question above was 2/3 of this. This question is just 2/3 kg. So what that means is you can take 7 over 8 kg directly minus away 2/3 kg. So that gives you your answer. Alright, convert them to the same denominator. So this is 8 times 3 times 3. This is times 8 times 8. convert it to the same denominator. But what I want to focus on in this question is now 7 over 8 kg, and he used 2/3 kg. So left is just 7 over 8 minus 2/3. The one above is I use 2/3 of this. So if I want to know how much I use, it's 2/3. If it's 2/3 of 7 over 8 kg, so that's how much I use. How much am I left with if I use 2/3 of it? So it's 1/3 left times 7 over 8. All right, so you have to know how to differentiate between these two and when to use just directly minus, because both are kg, then you can minus directly. If it's 1/3 of it, then you need to multiply instead. Find the product of 5, 8 and 4, 9. So 5 over 8 times 4 over 9 equals to, so what I like to do is just draw a line here, and then everything on top just multiply. So 5 times 4 over 8 times 9. All right, you get 20, 72. And then you just simplify this to the simplest form and you will get the answer. 5 children share 3/4 of a pizza. What fraction does each child get? So you have 3/4. You divide it by 5. All right, so that's how you do. Because you have 5 children, so you divide it by 5. So I just work it out for you. 3/4 divide becomes times. This is actually 5 over 1. So you have to flip this, becomes times 1 over 5. Again, draw the line in the middle. 3 times 1 over 4 times 5. And you work out the answer. I express 13 over 5 as a mixed number. So 13 over 5, mixed number. So you put 5 here. I'm doing the long way in case the number is big. So 5, and then you take 2 times 5 is 10. That remainder of 3. So this is your whole number. So it's 2. And this is your numerator. This is your numerator. All right, this is an easy question. So you might think this is very easy, but sometimes the mixed numbers can get a bit complicated. So this is the numerator, 3. And this is the denominator, 3 over 5. All right, so take the whole number and then times this. The remainder is the numerator. The denominator is the 5. There were 120 apples, 120 oranges, 3/5 of the apples and 2/3 used. How many apples were used? Okay, so I have apples, I have oranges, I have 120, I have 120. All right, so this again is my mathematical structure. All right, so learn how to do this. Every time you have some items, put it on top, and all the changes, you put it on the left side. So used, so I want to find used is 3 over 5 and 2 over 3. How many apples were used in the party and how many more oranges? Okay, so I know how many apples, so I need to figure this number out. How many more oranges and apples? So I also need this number and I need this divided by this. All right, so let's take a look. So it's 3/5 times 120, you get the answer. 2/3 times 120, you get the answer. And then you take this answer minus this answer will be how many more oranges than apples were used. Okay, so go and do this yourself. Last year, 81 pupils participated in a quiz where there were gold, silver, or bronze awards. 2/3 won either a gold or a silver. 12 of them won bronze. How many pupils did not win any? All right, so gold, silver, bronze. So again, I list them out in my mathematical structure. So I have gold, silver, and bronze. And then 2/3 won either a gold or a silver. So 2/3 is this. 2/3 won gold or silver. 12 of them won a bronze. Did not win is question mark. All right. So total, I know I have 81 students. So total is 81 students. So I need to take 2/3 times 81 equals to, this is the value. So this is the value. So I take 81 minus away 12, minus away this value. All right. And that will be equals to my did not win. So for this kind of problem sums, I want you to get used to writing what I call the mathematical structure, because it will help you to visualize the question much easier. And then from the mathematical structure, you can decide whether I'm going to use some models to draw or I'm going to use some branching method, or whatever method that suits best, right? But this mathematical structure is useful to help you make the problem sum easier to understand and less stressful for you as well, all right? And also less careless mistakes. So especially when you have this long giant problem sum where there are so many people involved and they are doing so many things that you don't even know where to start from, then it's always useful to create the mathematical structure first. All right, so always is the people on the first row, what they do, the changes in this column, and all the values are in the middle. All right, so if you watch my videos, the other videos, I will be using this again and again and again and again and again and again and again. Okay, so learn it and apply it, practice it, get used to it. And this will help you a lot in reducing your careless mistakes and being able to understand the question better.